Hey guys, welcome back. In today's video, we will be covering about streaming in Mule 4. This is being very useful when we are developing our Mule applications. So let's get started. I'm going into the presentation mode. So what are the actual problems if we don't have streaming option enabled? So there are these screenshots I have attached over here. So what it does, the first one suggests like if the payload is being consumed once, then it will not be available for the second event processor. So if it is being consumed at this particular event processor, then it is no longer available for the next event processor to consume it for any other purpose. Similarly, the parallel consumption of data stream is also not possible in case of a scatter gather. So these are just two um, uh, examples which are on top of my head in which data streaming is useful if available. Otherwise, we need to make a lot many uh, fixes in between, like putting some variables in between somewhere just to lock all the payload, and even after that you are not pretty much sure about the performance of your entire flow. So what is streaming in Mule 4? So if you look into this particular diagram, it shows like there is a flow with file listener to be starting, and after that there is a payload, logger payload, and then there is a file write. Now this file listener is being marked as non-repeatable stream, which states like it is being available only for once. Now, if the same payload is being available till a logger event processor, then if we want to use the same payload at file write, it will not be available because it is being already consumed at the logger level. Similarly, it is being stated here as well. So Mule application have always been able to process input streams. Mule 4 enables an already consumed stream to be consumed by a subsequent event processor. Instead of having to read a stream into memory for a repeated processing of payload, Mule 4 processors can consume the same stream both in sequence as well as in parallel, and no explicit configuration is being required. Okay. In the second line, it is being mentioned like we can make our Mule 4 application to run similarly or run with the same behavior as in Mule 3. And for that, we have to add this particular tag, non-repeatable stream. So let me quickly go back to my Anypoint Studio to give you a glance about it. So as you can see, the very first one which I am currently showing you, it is Mule 3 default, how Mule 3 application works. So basically, I am trying to listen on a particular directory. Within it is being available within the main resources input, and it looks out for a file name pattern as .log, and after that it moves to a folder processed with the process.log. Now the main thing over here is if I go to the configuration XML and look out for this particular Mule 3 default, uh, here you should be able to see this non-repeatable string stream tag. So what it will do, it will make sure like your data, your this particular flow behaves exactly in case of Mule 3 if it being created. So in the logger component, what I have done, I have just tried to consume this payload. Since it is being used over here, it will not be available at the write activity. So let's try to give it a try. I'm running this project and I will put something on the src main resources as log under the input folder. So let me name it as one.log. I'll put hello world. You can have any string, not a problem. And let's wait for this console to show like this application is up and running. I'm doing a butt rep. So now here you can see the hello world is being printed using this logger. After that, it is trying to write it again in this write, but it is not being available. So Mule retry has been exhausted, and it shows exception was found while trying to write onto this main resources output one.log, and it enters into this on error continue, and it finally comes out of it. So just to show you one more instance of it, let's try to put this one more logger, and I will put something like this second logger, and we'll try to put, and let's try to see what it shows. It should be up in a moment. Let me try to refresh this input directory. So now it is being gone. So I need to create one more log file. Again, I will name it as one.log. One.log. In the meanwhile, our application is up and running. So typo is allowed, right? So if I go back to the console, oh, I need to push this one.log inside this input folder, then only it will trigger. So let me stop it over here, and I need to clean a bit over here. Uh, Process log I need to clean. But the main essence out of it over here will be, let me show you the console. You should be able to see could not read the input stream, right? I'm just trying to go to the first occurrence of this error. Okay, now here we go. Let me, yeah, it's already in the stopped state. So payload, after that it is entered into the, no, this one. There are some live changes which I am doing directly on the program, so just bear with me. Okay, yeah, so this was about it. This logger and second logger, and I'm trying to put the payload, but it says could not read the input string. Reason being, it is being already been consumed within the previous log component that is over here. So that's why this is the default behavior how Mule 3 responds back if we don't have a repeatable stream enabled. And again, just to show you, here we have used this non-repeatable stream tag. So the idea here was just to make sure Mule 4 also works in this Mule 3 behavior. So I was just trying to depict that thing. Now going back to our slides, Mule 4 introduced repeatable streams, which is a default framework for handling the streams. Read the stream more than once and concurrent access. These are the two main themes about it. And as a component, consume the stream. Mule save its content into temporary buffer. We will be talking about it. And the runtime will then feeds the component from the temporary buffer, ensuring that each component receives the full stream, regardless of how much the stream was already consumed by the previous component. A fresh copy of the same payload will be again available. in the form of buffer, and all repeatable streams support parallel access so that need not to take care about whether two components are trying to read the same stream when each component is running on a different thread. Mule automatically handles this balancing. When a component A reads the stream, it doesn't generate any side effects on the consumption of payload on component B. Now, streaming strategies. So, file stored repeatable stream that is default in Mule 4. It is having a in-memory buffer of 512 KB. For larger streams, it creates a temporary file to the disk to store the content without overflowing your memory. So, what does it mean? Like it will initially use a in-memory buffer up to 512 KB, of course configurable, and after that it will create a temporary file and it will push out all the contents onto the disk. So if you need to handle large or small files, you can change this particular buffer unit and the buffer size. And configuring a larger buffer size increases the performance by avoiding the number of items the runtime needs to write, but it also limits the number of concurrent requests your application can process. So the thing here is if you are trying to increase the buffer unit, then of course it will be able to handle more number of records in one shot. But the time it will take to load all the records, it will give an impact on your performance as well. So you need to have a optimum level of balance between the what should be the buffer size and how much records you are trying to pull in into your system. A smaller buffer size saves memory load and it will be repeated multiple times. So based on the performance testing, 512 KB buffer size configuration doesn't significantly impact performance in most of the scenarios, and that is being tried and tested. I will also show one of the test cases around it. But in case you are playing around these particular values like in memory size and buffer unit, just make sure you are running multiple rounds of performance testing before going into the production phase. So going back to my Anypoint Studio, I'm just trying to show you one more aspect of it. So if I go to the advanced under the on new or updated file, this is the default repeatable file store stream. So in memory 512 KB, and after that it will disk out to the on a particular file storage, and the buffer unit you can choose out of any of these, but default 512 KB works very smoothly. So just a word of caution, if you want to update it, go with multiple rounds of performance testing. After that, there is a read component which I have placed, and it is trying to read from a particular stream.log. And after that, there is a logger which is trying to consume it. And then I will again try to read out from the payload, which is being the output of this read. And within the advanced, I have done nothing, so it's plain and simple. So let's uh, try to understand this particular flow as well. Okay, I have cleaned it up. So, so what I'm going to do, because this is pretty much straightforward. So what I will do, um, stream.log. Okay, I will rename this particular file and okay .log. So let's rename this file. So I will name it as stream.log. That should be fine. And if we go to the log to the flow level, I have put it down into the stop state. So let set the default, and I will set this as stop state because I don't want both flows to run in parallel for now. And let me delete this output and I will run it again. So again, idea over here is there is a log file which will be picked up by this particular flow. It will try to read the content. We will first try to consume that payload, and then again we will try to see if we are able to write anything using this write activity. So we should be having something inside this output folder mule for stream.log. Let's see if it is reading it out or not. So the first message is being picked up, that is this one, and after that it is gone, right? So let's try to refresh the streaming project altogether, and we can see within the output there is a file created. Let's see the content out of it. So we can see the same content. So it with this Mule for default, what I have tried to show, like even if it is being consumed at the logger component, it is still available for the consumption at the write file activity again, which was not in the case of Mule 3. So I'm going to stop this flow and set it in the stopped state for the time being. Again, I'm going back to this particular uh, PowerPoint presentation. So the next thing is similar to this file stored that is default in Mule4. There is an in-memory repeatable stream as well. So what it does is like in-memory default is the default setup configuration for Mule kernel, that is community edition of Mule runtime. So for larger streams, the buffer is expanded by incremental value of 512 KB until it reaches the maximum buffer size. To just give you a glance of it, how it will look like. So if you go to the advanced tab and go for this repeatable memory stream, initial buffer size it will start with 256 KB, and every time it is trying to increase it with 256 KB, and after that you can put a higher value over here, maybe 1024 or something. After that this is the maximum size of the buffer, and if the stream exceeds this limit as well, the application will fail, stating like you have crossed the heap size or heap size not available or something like that. You can customize this behavior by initial size, initial buffer size, max in memory, and buffer size increment. Here it is giving an example, like initially starting with 512, with every time 256 KB will be incremented, and it will wait for 2000 KB of max memory size. Again, this is the preset, you can see the default setting for in-memory repeatable stream. I will not say default. Default is 256, 256, 256. Okay. Now going to the next one, component-based streaming. So in most of my example, I have used this file-based. Apart from that, Salesforce Select and Database Select, all these uh, FTP, HTTP connectors, sockets, these also support the streaming options. Basically, it returns an input stream and a streamable collection which supports repeatable streams. So what I'm trying to say, um, okay, I will try to cover in this very last demonstration, maybe this particular input stream and collection showing the repeatable streams. Okay. Now the streaming objects, when an endpoint connector is configured to use auto-paging, Mule4 automatically handles the paged output of the connector using a repeatable auto-paging framework. Auto-paging means buffer in, check it out from the file storage, then bringing it out again. This framework is similar to the repeatable string because the connector receives the object. Mule sets a configurable in-memory buffer to save the object. However, repeatable streams measure the buffer size in byte measurements. The runtime measures the buffer size using instance counts. So instance counts, this particular concept is very handy in case of database connector. It will count on the basis of instances, how many instances or records do you want to capture in one shot. And when streaming objects, the in-memory buffer size is measured in instance count. So we will be covering this as well. Now it is talking about with respect to SFDC, like in-memory objects is being 100, and when we are querying in-memory for a query from Salesforce connector. So basically, the default configured in memory is a buffer of 500 objects. And if your query returns more result than the buffer size, Mule serializes those objects and writes them to your disk. This serialization and deserialization is being done through CRYO framework of serialization. You can refer to the standard Java documentation to understand more about the CRYO framework. So the Cryo serializer, which doesn't have this limitation, is capable of serializing some object that standard Java serialization cannot. However, Cryo cannot serialize everything, like Gregorian calendar implementation are not serializable, even though MuleSoft also recommends to keep all the objects in a very simple format, not in a complex structure. Now, this is talking about in memory. So basically the idea here is if the query result is large than the specified buffer size, then the buffer expands to the default increment size of 100 objects in this case until it reaches the maximum buffer size. Even if it crosses this maximum buffer size, the application will fail. So you can customize these initial buffer size increment and max buffer size. But if you still don't want to take it forward, the way could be to use this option, right? Um, Go to the advanced and drop down non-repeatable stream. Or second option could be on the flow level itself, like I have shown you non-repeatable stream. Okay. Although disabling repeatable stream improves the performance, the significance of that gain is proportional to the size of streams. Unless you are working with large streams, it is likely that you can do something else in your app to provide a better optimization. So um, streaming is very useful in case you are handling large volume of files, large number of records. We will take an example in which we will be dealing with 50K plus records and how smoothly it works with streaming. So now it is referring for the other components as well. So just have a look. The cache component, some transformation through the transformation message component, for each component when iterating through a JSON array, any other component that accesses the stream directly or through an expression. Now this file stored input stream. So I have just shown you like how we can see, and but the main description is quite catchy over here. In-memory size defines the maximum memory size for the stream to keep the data in memory. If more than configured amount is consumed, strategy starts to buffer the content onto the disk. It starts with in-memory. If it is crossed the overall buffer size of in-memory, then it will default to the content on the disk. You can set this buffer unit in KB, bytes, MB, GB. In memory. So in memory, the same concept will be there. In case it crosses the maximum in-memory size which we have set, then a stream maximum size exceeded error will be raised. By default 1024. Buffer size increment, how you want to increase, like from setting up from the initial 256 KB, every size increment will be in that increment only, and it will error out if it crosses the maximum in memory size as well. Of course, all these parameters are configurable. You can change it as per your business use case. So I have covered this particular Mule 4 with Mule 3 settings, and even this one in which I have shown you like even if it is being consumed at this logger, it is still available for the consumption at the write file activity. So the last one which I am trying to showcase here will be Mule for large file handling. So how it will be basically, we will be triggering this flow with the updation of a particular file. This is start time just to make sure we are doing basic household activities like when this flow is being initiated and when it ended so that I can calculate some time elapsed. Then there is a logger trying to read a particular file. I will transform it using the iterator. Then there will be a for each for all those payloads. We'll try to transform and write onto a particular file in the appended mode, and finally it will end with a logger. The main thing will be this file which I am going to read. It will be quite heavy in its size. Number of records will be quite long. So let's go back to our Anypoint Studio. So this was the flow which I was referring, and let me start the console. I just want to have a look. What is the name of the file I should provide? 1.csv, my favorite one. Now there is a read. It is again reading the same. Okay, that's good. And rest of the thing will be okay. And just want to cross check what is the write file process csv. So I will delete this one. Okay, now it's good. I will copy paste this last CSV into my input folder. I will rename it with 1.csv, maybe 1.csv. I will go back to the console. It is showing me it is being failed. Let me check. One moment, guys. So what I will do, I will quickly. Maybe I can delete these things. Not delete. Let me see if there is any problem. Want to have this in max in memory size and repeatable in memory, so it's definitely about the second one. Okay, I'm just trying to solve something over here. Let's try to see if this fixes this issue or not. So all good, rest apart from it. I will wait for this console. Yeah, so the file is being picked up by you by this particular, and now this loop is running with this logger printing loop finished. Okay, loop finished, and the final thing will be this logger saying process ended at this particular time. I will go back to the console. It will take around 30 seconds to complete. So 8:57 we started, so let's wait for around 30 seconds more. Just to give you an idea about this last CSV, so how it look like. Um, I will go back to my uh, workspace. Streaming, not target. It will be in the SRC main test resources large CSV. I will open it with Excel. In the background you can see a lot many things are coming up, loop finished, so it is trying to uh, repeat it for every 50,000 messages, right? Mhm. I just want to show you the counts in the main file which is being under processing. Still it is running, quite heavy file. So it took 40 seconds around, and it finally completed all the uh, processing of the flow. I'm just waiting for this original file to first open up. Let me refresh this processed folder. I can see this new file has come up. Okay, okay. Um, Still taking some time. I will force quit and I will try to open it again from background. I just want to show you the original large CSV file first, and then we will compare it with the number of records it created under this, right? So I have used over here as for each, just to make a connection between each records in a particular order. You can have any other strategy as well. It's taking a lot, as I was expecting. Okay, it's good, at least my other editor was able to open it. Ah, both have turned up now. So just to give you a count how much it is. Oh, somewhere around five, this much count, right? So if I exclude the header, this is the original count. Okay, 500,000, right? 500 triple zero. Okay, now what I'm going to do, I will just try to compare it with the process CSV. So opening these files is always a pain. Let me go back to the main resources and process CSV. Open with, um, I will use my editor. Pretty much same, right? If I exclude the header. So coming back to our original discussion, this particular flow was just to let you know how we can use streaming flow, and we can consume it multiple number of times within the flow without thinking about the original size of the file. There could be a second approach to it. You can use batch processing or batch strategy for its consumption, but if you want it to be synchronous, this could be a possible option. And apart from that, there are many other considerations as well. Like, I just want to showcase something. Like, if you go to the preferences and search with max, maybe it should turn up. Buffer. Oh, it's not turning up. So let me go to the Anypoint Studio. So this particular max file size to pass model to from configuration files. This is also you need to keep in mind, like what is the maximum file size it can pick it up, but it is in bytes. So this is something you can play around. And apart from that, if you want to set some um, configuration level, one second, it started again. By mistake, I clicked it over there. But go to the run configurations, go to the arguments, and this particular property you can add. Again, this is in bytes, so you can convert it into the equivalent MB if you want to understand it more. But this was to make sure, like streaming memory, how much it will take. So this is also you can add this again with a word of caution. It should go with multiple rounds of testing. See, okay. And there are apart from that there are many other things as well, but that are on the DW level, like how you can set the maximum buffer size in the case of uh, let me show you that as well. Data we memory management, not the memory management, streaming. Um, maybe this one. So in case like if you are handling small files, then there should not be any issue, but if you are handling very large files, then there are chances like you can turn up in situation in which the temporary directory is completely filled, so you want to change it to some custom directory. So you need to change using this particular property java io temp dir. Let me show you if I have opened it already. Mhm. So I should be having something over here. Mhm. This is my Mule instance local. So if I open this one, wrapper conf. So here I have added this. You have to add for a new Java property, Java temp file I am trying to add, and then you can specify any folder, the customized folder. Advantage will be you can manage it more easily as compared to the automated, which is like very difficult to trace. Apart from that, there are three buffer files which are being generated for output, input, and for the index. Default size is 1572864, and this is by default. If you want to change this size, com MuleSoft DW buffer size, you can change this particular value by adding it onto the wrapper conf. And this index is being used to store the information of value being read. This helps data we access data quickly. So this is just for the internal management, but if like in case you are using for each loop, which I have just shown you, like when the stream ends, when for each finishes its execution. So it is making use of these particular temporary data view buffer files. Again, it is talking about the different other options, like how much memory allocation is being there, like 1.5 MB, and monitoring purpose. This monitoring purpose is mainly for retry and other monitoring stuff for a particular component. For memory pool size, default 60 slots are there, and you can allocate or deallocate the heap size memory accordingly. There is a direct buffer which is being you can mark it as a disabled. So DataView uses this off heap memory for internal buffering, and however setting this can cause problems. So these are default settings. We should not change it, but for your customization you can play around with this buffer size, this memory allocation, and worst case scenario this memory monitoring. The main thing will be the buffer size and the memory allocation, which we can play it around. And apart from that, how to configure the customized location of your data weave custom directory, you can refer this particular thing and you can place it in the wrapper.com. So this was all about this streaming, which I have tried to elaborate in terms of concept and some demonstration sessions. I hope you like this video, and thanks for watching and have a great day ahead. Thank you.